Today is Wednesday, March the 10th, and we are still working on exploring fractions. We're learning to identify regions that have been divided into equal-sized parts and divided regions into and we are actually dividing regions into equal-sized parts. We're learning this so it will help us solve real-world problems, especially when measuring tools differ. We use measuring cups, we use measuring tapes, we use measuring rulers. We even divide our food into equal-sized pieces when we're cutting pies or cakes. So we want to think about how those fractions are represented in the real world. So we're going to be using models to show the two fractions are equal eventually. That's what we're going for. And we're going to be able to see that by using those models and laying them on top of one another to see if they're equal. So we've been doing that the last couple of days in math class. We've been using that virtual manipulative slide to help us with that. And we're going to continue to use that using different shapes. Today our focus is going to mainly be on looking to see if the regions are cut into equal parts. So today's lesson is going to focus just on whether or not a particular shape is divided into equal sized parts. So our question that we're going to focus on is how are fractions used in the real world? How do we use them? What do we do with them? Do we use them every day? Is it something that we're going to have to be able to use to cook, to build something, to share something equally? So we got to think about those things, and do we use it every day? Well, I do. I do use it every day, not just because I'm a math teacher, but because I cook every day. I'm using a measuring tool daily to do my dinners for my family. So I do use fractions daily. And again, there's our lesson target, so you can look at it again if you need to. Our focus, like I said, was going to be determining whether or not a shape is divided into equal parts, or the regions are divided into equal parts. So we're going to think about that, and we're going to select those that apply. So if you're looking at these particular shapes, we see that they are divided up, but are the parts equal? If I laid one upon the other, would it be equal? So let's look at the shapes that we see. We see a square, we see a triangle, we see a pentagon. So we're looking at these three shapes to determine if the parts are equal. So if I'm looking at the first one, which is a square, I see that it's split into half. I'm thinking about looking at that particular piece. If I were to fold it over, would it be equal? So again, I'm thinking about what this represents here. If I have a whole that is broken into two parts, how would I look at that in regards to fractions? So we all pretty much know, because we've shared with a friend before, a candy bar or something that we would split down the middle and make a half. So we're trying to determine if this is split into equal parts where we each get a half. And looking at that, I think that we can all see that this one would apply. This particular shape is cut into two equal parts, meaning that one side represents one half and the other side represents one half of the whole. Now let's look at the triangle. If we're looking at the triangle, we see that it's split into three parts, and we're trying to determine if the three parts are equal. So if I were to look at this particular shape and try to fold those parts over, immediately my eyes are seeing this part doesn't look like it's going to be equal with this part, nor this part. So even if I folded this in a different way, I'm not seeing equal pieces here. So in this case, this one would not apply. Now let's look at the pentagon. The pentagon is cut into four equal parts, meaning that each section would represent, if they were equal, 1/4. So each part would represent 1/4. But when I'm looking at this particular shape, I'm also seeing that it does not apply because my pieces are not equal, are not equal. So in this case, the only correct answer would be the square, and it is cut into equal parts. Okay, we're going to do the next view, and we're going to do the same thing. We're going to look at each shape, and we're going to try to determine if it's divided into equal parts. So the first one that we have is a rectangle. This rectangle is broken into 4 pieces. As you're looking at that rectangle, immediately you see this larger section here that is cut out, and then you have a couple of smaller pieces, and then one that's kind of in the middle of the larger piece and the smaller pieces. So we can immediately see that this is not cut into equal size parts. So this one would not apply in our answer here. The next shape that you see is a rhombus. This rhombus is cut into 4 equal parts, so meaning each part would equal 1/4 if they were equal. And when you're looking at that particular shape, you can see immediately that if I were to fold those, that those pieces are equal. So this one would apply, this answer would apply, and each section would be represented by the fraction 1/4. Last shape that we have on our page is a triangle, and this triangle is split into 2 parts, meaning that if they're cut equally, that they should represent 1/2 of the shape. So if I'm looking at this triangle and I'm thinking about, in my mind, I'm always folding my paper. Like I'm folding that triangle, thinking about whether or not those pieces would equal the same. And when I look at this particular triangle, I see that both sides are equal pieces. So each of them would represent 1/2 of the shape, meaning that I would have a fraction that had a numerator of 1 and a denominator of 2. Remember in class we've been discussing that the denominator represents how many parts it takes to complete the whole, how many parts it takes to make up that whole. So when we look at that, the denominator is always going to tell us how many pieces that whole was cut into. And the numerator tells us how many pieces are included or how many that we're looking at. So if I'm looking at a shape that is cut into 2 pieces and one side shaded and one side's not, and I were to ask you the question, what fraction represents the unshaded part of this shape, then you would tell me that it's 1/2, 1/2 in our fraction. Alright, I hope that you guys are enjoying fractions and the exploration that we've been doing with them, and I hope that the word fraction doesn't scare you like it did at the beginning, because as we're looking at those, we're seeing how we can put those things together and do those shapes on the virtual manipulative slide. Again, if you want to use that today and practice it, because we are using it in class, and I noticed yesterday that some of us were still struggling with using that. Remember not to be fearful of it. Just try it. Lay them on top of one another. You can pull those over, those fractions over, and I'm going to go ahead and pull that up for you as well so that you can see that you can pull those over on top of one another to look at them, to see if they're equal, to see if they make a whole. So I'm going to go ahead and show you quickly again how to use those to help you with those fractions. So remember that we also talked about that size of the whole is important. If we're thinking about a fraction that is looking at just the whole itself and the whole circles, like we're filling in the circle and the whole circle's filled, and we're looking at something that would complete this one, I could actually pull this one over and I would be able to tell that it takes 2 pieces to make that full circle. When we're looking at a different aspect of it, if I'm looking at this as the whole now, the one that's shaded in this circle, then I could think about how many of this particular shape would it take to complete that particular circle. So I'm thinking about this one here. If I were to bring this one over, how many of this blue would it take to fill the hole that we have here. So in this case, it would take one more blue to fill the hole in this case. And if I were writing a fraction for what part of one of the blues would be in regards to the hole that I'm dealing with now, it would be 1/2. 1/2. So I would write the fraction as 1/2. Now remember, we can look at different shapes and we can pull those around. We could actually flip this around. So just practice using that, because we are using it in class every day, so that you can familiarize yourself with it a little bit more. And remember that when we are doing fractions, we want to make sure that they're covering the whole region that is considered our whole at that time. So think about what we said about size is important, knowing what fractions, what parts that we're dealing with as considering the whole. Just like our candy bar illustration, we have the king size candy bar and the little fun size, party size candy bar. Remember, we talked about if we were thinking, and I asked you, would you want a half of a candy bar or a whole candy bar? And I pulled out that big king size candy bar, which represented our half, and our small fun size candy bar represented the whole. It made a big difference in what we would have chosen. So make sure that you think about what is the size of the whole that we're dealing with. And in this case, we were looking at the half. So just play around with that website, get more familiar with it, and I hope everybody has an awesome day. Look forward to seeing my brick and mortar kids again tomorrow. It's been a great pleasure to have you in class with me. And if you have any questions, be sure to hop on. Today, I will only be giving multiplication tests to those students who are virtual students. So if you are brick and mortar, then you will not take your multiplication test until tomorrow. I hope everybody has an awesome, fun Wednesday. Enjoy your day. See you all later.